Welcome to our webinar introducing perClass Mira 5. This is the first of 3 webinars with the same general content, but a live Q&A for all 3. This webinar will be recorded and should be available for viewing within 48 hours of the close of the webinar. We'll answer as many questions as we can during the broadcast. If you have additional questions, you can also send them by email after the conclusion of the webinar. Our agenda will include an introduction to Headwall and perClass, related products, hyperspectral imaging used for machine vision, recorded demonstration, and live Q&A, where you will use, of course, the text chat to the panelists, and a wrap-up. The questions panel in your control panel can be used to type a question. What I will do as the host will be to ask those questions of the panelist. And speaking of panelists, our panelists are Christian Felsheim, General Manager, Machine Vision of Headwall Photonics, and Dr. Pavel Paclik, Founder and Managing Director of perClass BV. With that, I will pass the baton to Christian Felsheim.
Thank you very much for that introduction, Ross. Yeah, welcome very much to our webinar. I'm talking to you today out of my home office, which is located in the southwest of Germany. And before we start introducing you into the new stage we would like, and the software, the new perClass software we would like to introduce to you today, let me talk a bit about on who we are and what we do. So Headwall at a glance. Headwall was founded in 2003, actually as an offspring, and we had been introducing hyperspectral imaging systems since, much of that in the remote sensing area, before we then joined Arsenal Capital Partners, actually only last year, in order to enable us to even further grow and bring hyperspectral imaging systems into more applications. Overall, we meanwhile have 4 sites. Well, Headwall by itself, it's based in the US, just outside of Boston, where we have our headquarters in Bolton. In addition to that, we also have 2 further sites where we work on the core of our original business, on what we had founded on, and these are optical components. And here we are doing a grating manufacturing in Fitchburg, which is just another half an hour east of Boston. And we also acquired a company called Holographics, which is in a great addition to our optical components business, and that is just located close to our headquarters in Marlborough, also east of Boston. Now, in addition to that, we meanwhile also have a nice site in Europe, in the Netherlands, where the perClass is located in Delft. And I will get back to that a bit, 2 slides later from here. Overall, we are about 100 employees, and it's really fun working with them because they are really experts in what they do. And we are a vertically integrated company. So we start with the core of spectrometers, which are the gratings, make spectrometers, also as OEM components, make the hyperspectral imagers, package that, whether this is a remote sensing package or whether this is a machine vision package, and then even provide you with the software to analyze the data. And that, I think, is maybe even the most important part of it. As software becomes more and more important to get a grip about the data and to understand on what we have identified. Okay, next slide, please. It takes a bit until my slides are moved. Our organization, or the organization of Headwall, is thus separated in 3 business areas. The one is machine vision, where we are addressing industrial applications, deploying systems over conveyor belts, or also in quality assurance labs. And that is actually the business which we currently see the most growth overall. A very nice adaptation of hyperspectral imaging in this area. Where we are coming from is, but on the hyperspectral imaging side, is the remote sensing business. Here we are packaging hyperspectral imaging cameras combined with other sensors like LiDAR, high precision CPS, IMU on drones or airplanes or even satellites to measure objects which are outside and provide very valuable information for research applications in the agricultural world, in the mining world, but also many environmental questions are addressed by our customers in that area. And then the third part, which is really the core of our original business on what we had founded on, is the optical components business. And that separates us a bit from other spectral companies, because we are really making and designing ourselves these gratings to purpose of the application we need it for. And that allows us to make the spectrometers as they are needed for the application. Next slide, please, Ross. Now, a bit of perClass at a glance. As I'd mentioned before, perClass is based in the Netherlands. Actually, it's a spin-off of the Technical University of Delft, a very strong technical university in Europe, maybe comparable to the Massachusetts Institute of Technology in Boston. And the vision of Pavel and his team was to provide software which will allow actually anyone to interpret these spectral images. Spectral images are not easy to interpret. You have a huge data set which looks very strange, and we will get back to that a bit later. And to enable anyone to take advantage of this technology, that was the goal of Pavel. And I think he and his team has done a great job to really bring the value of hyperspectral imaging and make that available to a lot of people who can benefit from that. Overall, perClass is meanwhile over 15 years in the business, having a lot of experience in industrial machine learning. And it was in 2018 when they really packaged all this experience in making a software which they call the perClass Mira software, which is a really easy to use software, but though very, very powerful package. And Pavel will talk about that surely later on more than that. Now in 2022, though we had worked with perClass before, we decided it would have been great to get them on board to really package it, make hardware and software one, not only a hardware package or a package to offer to our customers, but also to make it one team to work on easy to use, powerful offerings to our customers. Next slide, please. And what we offer here will show you is a bit shown in the next slides, just for a part of our machine vision business. These are three different spectrometers we offer in our machine vision business. On the left-hand side, you see a camera that would cover the wavelength range from 400 to 1,000 nanometer. We call that the visual near range or V-near range. It's a very compact camera, quite fast, so it can also cope with faster running belts, and very, very compact, so easy to integrate over a line or into other instruments, quality assurance measurement instruments. And that has given us a great entry into the machine vision business. In the middle, you're seeing our most recent addition to the MV spectrometer line for the machine vision. This is our near camera, covering from 900 to 1700 nanometers, and actually that's even faster. And actually, it's one of the fastest spectrometers in the market, giving you up to 547 frames per second at a size of 640 spatial pixels. And that is really great to also to go inline. But it's not only the inline, it's really also the quality of the spectrometers. Remember that we are making the gratings ourselves in order to really adapt it to the need of the hyperspectral imaging applications. And that is what gives the customers advantage of a high quality spectrometer. On the right-hand side, a very special product of ours, and that was the first time when we really worked with Pavel and his team. That is also a V-near spectrograph, so covering from 400 to 1,000 nanometer. but it's done all this number crunching, all this analysis of the data embedded on board in the system. So it does no longer give you like a huge data set out, which then has to be analyzed by another computer, but you are immediately getting the analyzed data out of the system. So an example, the position of a foreign object or the sugar value of a fruit comes directly out of that system. And as I'd mentioned before, that was the first time when we worked with Pavel and his team, and we got really excited about it, because the perClass software there is a runtime version of the perClass software which is just executed on that machine. Very exciting. So when we brought that to market, we were actually quite proud that we immediately got two prizes, two innovation prizes for that product, and that recognition is certainly a nice confirmation of our ideas. Next slide. We're not only providing these systems for inline inspection, but we actually are seeing quite a big demand and requests coming for offline systems. So systems where you can put hyperspectral imaging at line or in the lab to really analyze and get a feeling for the power of hyperspectral imaging. And that's why we combined these spectrometers, which we have seen before, with the first hardware product that actually perClass developed, and that is a stage. It's all integrated, very easy to operate, and Pavel will show that also later on. And that also comes with the perClass Mira developer software, and that is really a great tool. It provides you with high quality scans, very easy to use. It has, you see these three little buttons in the front, where we very quickly can acquire larger sets of data to build a robust model on the analysis of the data. It comes in a very rugged case. It's easy to set up and to collapse again, and so it's also movable. If you have multiple size, you can easily carry it from one side to the other. And it's really the perfect tool combined with the spectrometers to try out hyperspectral imaging in your application and get a good understanding on where that gets you. Next slide, Ross. Okay, if you want more information, that's all available online. So please feel invited to come to our website, headwallphotonics.com or perplus.com, where you find application notes, training videos, other applications, and I'm sure Ross will also upload the recorded video of this webinar up there. So feel free to get to that for further details. Now, and with that, next slide, Ross, I would like to hand over to Pavel, which is here with us today, and which I'm very happy about. However, he will start. Oh no, first sorry, I've missed that. We're not getting there yet. Before we are coming to the software of how to analyze hyperspectral imaging, for those who might not yet been very familiar with hyperspectral, just a quick reminder on what we are talking about. Ross, I need to get you one slide back, please. Yeah, thank you. So hyperspectral imaging is about analyzing, let's say, color, but not only color as we are perceiving it in terms of red, green, and blue. It's not only 3 channels, but we are talking about hundreds of channels which we analyze in the spectral bands. With the V-near, we are talking here about 300 channels. In the near, we are having 200 channels. So rather than just as a color, we are really looking at many planes of the information. And if you look at the plot here in the middle, you are seeing plotted over the wavelength. You see the intensity in every single wavelength, and that gives you this spectral profile. And this profile is like a fingerprint of what you are looking at. Now, if you are going to the next slide, just cycle through until we see all of everything. Wonderful, thank you. So here you are seeing the value of these fingerprints. In the left picture, we are showing a few samples of different substances. It's different mixtures of powders, which we, by our naked eye, wouldn't be able to differentiate, because to us, they look all white. But if you look and really do a thorough analysis of the spectral content, as you could do with a hyperspectral imaging camera, you see that these substances aren't the same by any means, but they have very profound spectral signatures, which allows us, analyzing these signatures, to differentiate all these substances very easily. And this is being shown in the right-hand side in the picture, where we are now using false colors to very clearly differentiate and classify these different substances. And Pavel will show you more about that, how this can be done. Now, and this was a bit quick for us, maybe we can step back. Now, as we are, now how do we get there? We are now talking about a camera which actually measures 3 dimensions. Actually, yes, the hyperspectral imaging systems are something like a spectrometer. So they're measuring the spectral content. That is the first dimension. Now, in addition to that spectrometer that measures the spectral content in a single point, hyperspectral imaging measures that across a whole line. So it's like 1,000 spectrometers in one single line. Now we have 2 dimensions. We have one spatial line and one spectral dimension, 2-dimensional image. However, we really not only want to see one line, but we want to see the whole set across, let's say, a belt. And we are doing that by either moving our camera, like we would do in remote sensing, fly the camera with a drone over an area, or like we do with our stage, we are moving our object under the camera. And that's what should be shown here on the left-hand side in the animation. The substances or the stage or a belt is moving under the camera. So we are getting, and that's the blue bar here, we're acquiring line by line. And then we add that to like an image waterfall, which you see in the middle, where we stack all these lines to come to our 3rd dimension, the second spatial dimension, and with the spectral dimension, the 3rd dimension of our data set. And this waterfall image can now be analyzed, as you see on the right-hand side. In this case, we are differentiating between the different substances we have on the board, so we can classify and identify on what we are looking at. This is the power of hyperspectral imaging, which is like, as I said before, it's like 1,000 spectrometers in a line. So it gives you, in addition to the spectral dimension of the information, you can now align this spectral information to every single pixel of your substance. And this technology, where you move like with a broom over your substance, that is what's been called the push broom hyperspectral imaging scanning technology. And with that, I now really hand over to Pavel, which you are seeing here on the board. However, we will start with a pre-recorded image of the demonstration of perClass Mira 0.5.
Hello, my name is Pavel Paclik. I'm co-founder and managing director of perClass BV. We are a software company based in Delft in the Netherlands. We have developed perClass Mira, a software that makes it easy to interpret spectral images. Earlier this year, we brought to market perClass Mira Stage. It is a lab scanning setup that can be used to quickly acquire high-quality scans, interpret them, and validate these solutions. Here we have the stage mounted with halogen illumination and Headwall MV near hyperspectral camera. The stage is easily portable. It comes in a single rugged bag and can be assembled without tools. Therefore, it allows you to bring the full setup close to your samples in diverse production environments. In this webinar, I am going to guide you through perClass Mira 5, our upcoming software release that is closely integrated with the stage. perClass Mira 5 makes the process of acquiring high-quality data, analyzing, and validating solutions significantly simpler and more efficient. I will use the quality estimation workflow as an example throughout the presentation, specifically the sugar content estimation in grapes. So what do we need in this workflow is to scan many examples of grapes, distractively measure their sugar content, attach this information back to the spectral images so that we can build a sugar estimation model using regression modeling, and finally deploy the solution. Let's start with the first major improvement in perClass Mira 5, which is efficient scanning workflow. You can now comfortably acquire 100 high-quality scans in 25 minutes. This means you can collect large data sets and therefore build better models in the same amount of time. The scanning process can be fully controlled from perClass stage buttons. You can now also decide whether you save the scan or actually retake it. Parts of file names can be separated by underscores. These parts can be then easily focused and incremented by mouse wheel, cursor keys, or a stage button. Here we have our system. We take an object, we put it on a table, and we press the green button to scan. Once the scan is ready, we decide to save it by pressing the red button. We put another object, press the green button to scan. Now we press the yellow to increment the scan counter and the red to save. You see the process is very simple. Put an object, scan with green, increment with yellow, save with red. Very quick. We do not need to reach for the mouse or keyboard. We can fully operate the process of scanning from the buttons on the stage. So in summary, scanning fully controlled by the stage buttons, retaking scan anytime needed, so you have curated datasets, and it's easy to keep structured information in the file names. In our projects, we collect hundreds of gigabytes of data. In perClass Mira 5, we developed an effective scan compression technique that significantly lowers storage requirements. It is designed specifically to deal with large training datasets. To enable scan compression, you only need an object classifier. This is only a matter of few clicks in perClass Mira. We define a background class and label some pixels to it, and then create a new grape class and assign some pixels of our product to this class. Then we can train a pixel classifier, and we assign the grape class to foreground so we can segment objects. That's all what is needed to apply compression when scanning. We switch to the camera and we grab a scan. The object detector will be automatically applied, and only the pixels highlighted in yellow will get saved to disk when we hit save. So this is a compressed scan with only pixels of the grape preserved without any loss. Let's grab a new scan. Often we are interested not only in the foreground, but some of the background. With the slider in the toolbar we can extend object boundaries, and when we hit save, the acquired scan will contain the foreground and some of the background, so we can build good classifiers along object boundaries. When we grab another scan, you can see that Mira is now able to stop when object is detected, and also trim the scans around the object. This helps us because we can place the product anywhere on the stage, and we always end up with small scans. The user is in full control. We can label anywhere in the scan the pixels we wish to preserve. We may also edit the mask and remove the parts not relevant to our application. Let's have a look at this project with full cubes from one scanning day of grapes. When we highlight the entire set, you can see it's 84 scans, in total 16.7 GB of data. When we look at exactly the same data compressed and highlight the full set, we can see that we have the same 84 cubes that occupy less than 5% of storage needed by the full cubes. In summary, perClass Mira 5 brings lossless compression of spectral data fully integrated in an efficient scanning workflow. User remains in full control. Building robust models. Already comprehensive regression modeling is now extended until per-object classification. perClass Mira has been offering regression modeling since the release 2 in 2019. We came a long way since this first release. We are now able to build robust models from hundreds or even thousands of objects, easily import lab measurement ground truth, understand performance with a range of common measures, clean the datasets with outlier scoring and error plots. We can understand where the errors happen and improve the models. In perClass Mira 5, we extend the regression modeling further into per-object decisions. Here I have an example scan with different grapes, and I have already built my regression model. These are per-pixel decisions. If I switch to object view, we have per-object segmentation. We can switch this into per-object decisions that in our situation would be all grape. But in perClass Mira 5 we can add 2 additional decisions, sweet and sour, and we can set up in the object panel a decision rule that will use these new categories. So by default the grape will be sour, and if the regression output is over a certain threshold it will become sweet. That gives us the decision at the object level and a quick way to see the change when we are adjusting this decision threshold. Integrating with existing perClass Mira tools, you can now estimate object confusion matrices for regression projects. This table summarizes decisions on more than 300 grapes. The sweet-sour ground truth is in rows, and the decisions are in columns. This tool gives us full understanding and control of the desired performance trade-off for our quality inspection or grading system. In the solution A, we do not throw away sweet grapes, but our customer will receive some sour ones. In the solution B, we preserve high purity of the sweet sorted output, but the rejections will contain some sweet grapes. In summary, we can now turn regression models into classifiers and have full understanding and control of the object level performance. That brings us to dual scanning. Often we need to decide whether V-near or near sensor is needed. We have developed a dual scanning setup, where with a single scanning effort you acquire 2 datasets. It is then quick and easy to find out which sensor provides better value to a customer. Let me show you this great new development that saves us a lot of time in our projects. Here we have a Headwall MVC near camera working from 900 to 1700 nanometers attached on perClass stage, and next to it the tiny Headwall MVC V-near camera working between 400 and 1000 nanometers. To work with dual scanning, you start by attaching perClass Mira instance to the stage and one of the cameras as usual. We can fully set up the scanning with this camera as needed. To work with the second camera, we open a new instance of perClass Mira from the camera menu. The original instance we call the master and the new one a worker. The worker connects to the second camera, here to the MVC near system. As you can see, the worker window background is blue. This makes it easy to understand for any dialog box or a pop-up whether you interact with the master or a worker. Using the dual mode is very simple. Each of the instances saves data to its own specific directory. When scanning, you only operate the master. When we click the scan button, the master notifies the worker and both instances start scanning. The file name is changed only in the master. Any change propagates to the worker. In summary, in perClass Mira 5, scanning with 2 cameras is as simple as scanning with 1. After your session, you can compare the 2 solutions and decide which sensor provides the best value to the customer. With perClass Mira 5, we are bringing an operator mode, which is a simplified solution for deployment that is easy to use by operators. perClass Mira stage is designed to go beyond expert R&D development and feasibility studies and help with solution validation close to production. Once we finalize our solution, we can switch the application into the operator mode, which is a very simple interface, session oriented. So we start a new session. Here we can see the data flowing in reflectance, per pixel decisions, and we can switch it into per object mode. So when operator puts the new product on the stage, what we can see is the bricks value per object, but also the object counts, mean standard deviation, and the histogram. So this is a simple tool to perform incoming goods inspection in lab or at line. The operator mode allows to distinguish developers who can change models from operators who can only apply the solution in the simplified interface. Actions and results are logged into a database, either locally or remotely. Other integration options, part of the operator mode, involve the application server that is built in perClass Mira that allows you to control both the software and the stage through simple text commands over TCP/IP, over network. So that enables you to do quick internal integrations and quick internal tooling without low-level development. When you are doing the low-level development of your application, you can use perClass as components. There is a camera API that provides the acquisition from a range of spectral cameras on the market, and there is a separate runtime API that provides the data processing. In summary, perClass Mira 5 makes it easy to validate solutions close to production, and there is the whole range of integration options available. That brings us to the conclusions for the entire presentation. I've been demonstrating how perClass Mira 5 unlocks the full potential of perClass Mira stage. It empowers you to build robust solutions in a fraction of time. Are you interested to explore these new options further? Then please reach to us and book your demo. Thank you very much for your attention.
That was excellent, Pavel. I am going to now let the audience know that you can use the questions panel in your GoToWebinar control panel. I see one question saying that the video froze for them after a little bit. I just want to let everyone know that if you did have any issues, we are recording everything, and we'll send you a link to see the full recording within 48 hours. I see other people had no issues. With that, I will start our questions and answers session. The first question we have for Pavel is when I update to version 4.0, this is presuming they have a previous version of perClass Mira, is the previous version still available to me in case for some reason I want to use it?
Okay, thank you, Ross, for the question. Yes, you can always install multiple versions of perClass Mira, and you can also use them in your computer as you wish. So there is no limitation, and moving to perClass Mira 5 doesn't prevent you in any way to use earlier software. We are always backward compatible, so you can load the older projects into newer versions. But if you save the project from a new version like 5, it may not open in the older versions. So it's a simple mechanism that we have been using for all the years so far.
Another question for Pavel. You may have covered some of this earlier, but this is certainly worth asking. Is the new scan compression algorithm lossless?
Yes, thank you for this question. So it is fully lossless on the foreground that we define this masking mechanism that we demonstrated in the video. So the pixels of the foreground are not changed in any way, and it's fully lossy everywhere else because we basically save space by throwing away things that we don't need, and there is actually no storage of this background data whatsoever.
Another question, which I answered a little bit earlier, just to let everyone know that I will be sending the link out to the recording of this webinar. Another question for Pavel: can your API be used with third-party stages?
Not really, because there is typically no API for the stages. So we have actually worked in the past with number of systems, and we have been actually using number of systems with perClass Mira. But when you go into the movement of custom stages, I do not know about any APIs that we could talk to. Sometimes you can talk directly to the motor itself, and we did some integrations like that. So people using, for example, InnoSpec cameras like Redeye can use the Spectre stage from perClass Mira, but we do not really have any integration for some stage level SDK, simply because there are no stage level SDKs available in the market, to our knowledge.
So speaking of the stage looks great. Are there, maybe this is a question for Christian, in terms of Headwall customer, are there replacement or spare stage platforms, the black plastic part sitting on the top, available for sale?
Yeah, we will make definitely replacement parts available, whether these are light bulbs or also the reference target. Just contact us and we will take care of your needs, for sure.
No, similar question. When I buy a stage as a package with the sensor, what does it come with? Does it come with the illumination?
Yes, the illumination is included, and that is actually one of the nice things of the stage, why I personally very much like it. It's really complete. It also has only one power supply. You plug everything in and then it's just one single power cord coming out of it. And that makes it easy to handle and also well sorted on your desk when you work with it and making it fun to work with.
Another question for Pavel: are third-party cameras supported by perClass Mira 5?
Yes.
Not Headwall.
Yeah, so that's actually a part of the strategy of perClass that we have declared together with Headwall also in the acquisition, that we keep, of course, support for all the range of sensors. So nothing changes. We are adding new sensors as well, and we are happy to support customers that come to us with some specific wishes in this. Nothing changes.
Yeah, and maybe I can also add to that. That is also Headwall's intention. We want to bring hyperspectral imaging to market, to apply this great technology, this valuable technology to many applications. And wherever you are in your phase, please talk to us. We are providing just components as a grating, or just a spectrometer, or just the software, whatever, wherever you are in your journey, contact us and we will be happy to support you in order to achieve your goals.
Another question: is perClass Mira 5.0 required in order to use the scanning stage?
It is currently not required. You can use it with perClass Mira 4.2, 4.2.9, I think is the current version that we use. But in the future, of course, we are developing both the software and the firmware of the stage. So there will be a moment where certain newer version will be required. We keep always the same mechanism for the updates. So people simply, when purchasing new permanent license, have 1 year of updates, so they can use any version. And if they keep on the updates, they can always use the latest version. So there should not really be an issue. We are not making any difficulties to move to the newest software. We always want people to use the newest software.
And this refers to some of the slides that you presented during the video, Pavel. A question about the confusion matrix graphics that you showed in the slide. Can those be directly output from perClass Mira?
Yes, you can actually, for many plots and confusion matrices, from the context menu, you can copy the content as an image, or in case of confusion matrices, you can copy it also as a text information that you can directly paste into Excel and actually use Excel or other kind of tooling for analysis of the results. So these images come from perClass Mira interface.
And another question, I'm going to address this to both of you, so both of you can address this. I recently purchased a Headwall MVC V-Near, which is the very small camera that you saw earlier, with a perClass Mira scanning stage. By upgrading to perClass Mira 5.0, can I simply add a new MVC Near to the existing setup to run both cameras simultaneously? So first, Pavel.
Yeah, so technically yes, because all the Headwall MVC cameras are supported, so you can start using also the MVC Near camera. If in this dual scanning example, it's clarified that one instance is one camera. So if you want to use dual system, you are attaching to two cameras from two different instances.
And then maybe for Christian, are there special mounts required? Do they come with the camera?
If you buy your second camera with it, we will provide you with the needed mount. Yes, indeed. And thanks for also giving me a chance to comment on that, because actually this opportunity, this option that Pavel and his team has to develop to really run both cameras in one go, and Pavel showed this very nicely in his video. We are very excited about that. Because that really allows you now to cover the full wavelength range from 400 to 1700 nanometers in one single go. And for research, but even more for application development, that is very, very powerful. Because in the end, what really bears the main costs of all of that certainly is to understand your application, to measure. And this where the power of perClass software, the stage, and now finally also the option of running two cameras comes in to make this very fast, very efficient and effective. And that's a great feature. And we like it a lot to help our customers developing their applications. It's great.
One more question for Christian. There is a case for the perClass Mira stage. How do the sensors come from Headwall? Are there cases that I can use to transport the sensors as well?
Oh, good question. Well, so far we have designed special cardboard packages, which are very robust to ship the cameras. So the cameras come in specifically designed cardboard packs. But just contact us, and we can certainly talk about on putting that in example into a more robust plastic box as well. Good input. Please talk to us. Thank you.
Question for Pavel. I like the operator mode. Is it possible to write the data displayed in the operator mode into some kind of report?
Currently not to a report, but as was mentioned, we are able to dump the data and to log the data into a database. So from the database, you can pull it to all different types of other softwares. In case that people have specific workflows, we are always interested to understand how people intend to use the technology. And we have been implementing exporting options to Excel, and we are also able to actually write PDF reports directly to disk. So I can imagine that if there is a need and a use case, we can make it happen.
This is a question for Christian about the Headwall systems. It looks like you were using interchangeable lenses. How do I determine what the best lens is for me? And can I determine what I see? I think they're referring to the field of view, depending on the lens.
Oh, thank you very much for that question. I really like it. Well, this has multiple aspects. Well, first of all, please keep in mind, not every lens you can use for standard machine vision camera. You can also well mount on a hyperspectral imager. You always need to look for the wavelength range that is covered by that specific lens. Well, we have looked at multiple different lenses and really qualified that. But still, you're certainly, and that's also one of our had been one of our design requirements. Our hyperspectral imagers allow you to change the lens easily. So if you have a first application where you want a rather larger field of view, you mount the one lens, and then if you have a second application where you need a higher spatial resolution, you can very easily screw in another lens. But again, before you do that, talk to us. So in order we can really help you to identifying a good qualified lens for your purpose. The second part of your questions regarding the field of view, yes, that is also very important to look at. We have a very nice tool which was created by our colleague Will Rock, and you'll find on our website. So if you go on our website, look onto support, on the upper right corner of the website, there's a little button support. You click onto that, you find tools, and under these tools, you have a field of view calculator, which actually has two tabs. One would be for remote sensing, well, this is also a very important question. And if you click on the second tab, this is about machine vision, then you can very clearly pin in whatever is specific for your application, the area you want to look at, or the resolution you need, and then it gives you these different types of answers depending on the wavelength range you select in the drop-down menu. If you have any questions about that, I can only repeat myself. Don't hesitate to reach out to us, and we are happy to help.
Similar question for Pavel. On the mounting rail of the perClass Mira stage, is there markings, or I think they're referring to the ruler?
If you mean the vertical beam, there is a ruler that allows you to easily see the height where you are mounting the camera, because you can have some preferred settings, and it's easy to mount the camera repeatedly to the same position. Yeah.
All right, some questions asking. We will certainly send links to the recording of the full webinar, including the video. We're running short on time here. If you have further questions, please make sure to send them to us. Coming up, the next trade show that we will be at SPIE Photonics West in San Francisco. We actually will have a booth, number 5519, at Photonics West. We will be displaying a demo featuring a perClass Mira stage with a Headwall sensor, as well as Headwall's perClass's offerings on display. As well as our the other company part of the Headwall group, Holographics, who specializes in OEM optical components, in booth 5633. Certainly seek us out. We will have our colleague Will Rock will be there, as well as Mikhail Jobran, our business development person at Photonics West. And if you have further questions, please use the email address on the right-hand side, marketing@headwallphotonics.com. You can ask us questions that we will respond to as soon as we can, whether it's Christian, whether it's Pavel, or one of our colleagues. We will do our best to answer your question as soon as possible. Special thanks to Will Rock and George Killian. George is our applications scientist, who you've seen in other videos, and Mikhail Jobran. Any final words, gentlemen, Pavel and Christian?
I would also like to ask actually my colleague Claire that helped me to set up to record the video. So that yeah. Thank you.
Excellent. Indeed, Leah should be on that list as well. She is a great support for our customers, a great application scientist. So thanks a lot to her as well. And thanks a lot for you to joining us today. Have a great day, and looking forward to get in touch with you.
Thank you very much.
Have a great rest of your day. Bye-bye.
Bye-bye.